Hello everyone, I'm Yiming Liu. I'm a PhD student working with Dr. Yibao from Stevens Institute of Technology. The research I want to show you today is a minimum deformation monitoring method. Our method uses a common communication technology of a coin size, which is called UWB, and a machine learning model is also applied to realize the deformation calculation. In order to achieve our goals, there are three main objectives. First, a suitable UWB radio system for measuring distance should be developed. Second, we utilize a machine learning method to determine bridge deformations from the measured UWB signals. Third, we use two error mitigation methods to improve the measurement accuracy. Now, let's see how the UWB technology measures distance. Here are two UWB sensors. One serves as a transmitter, and the other one serves as a receiver. And the distance between the two sensors can be measured by analyzing the received signals. In the left figure, we can find the emitted signal has one peak, and in the right figure, we can find the received signal may have many peaks, which are due to the reflection and the scattering. The first peak in the received signal is difficult to be found, but the first peak is very important for calculating the distance. Compared with other methods such as GPS, computer vision, laser scanning, UWB technology has many advantages. A UWB chip is less than $20 and it needs a low power supply. The sensor size is small. The distance measurements are robust to the weather. For example, we can use UWB to measure distance when it's raining. Therefore, UWB has been used in some advanced fields, such as automatic driving and robots for indoor positioning. Last year, Apple put UWB chips into iPhone 11. We can see that UWB technologies are attracting increasing interest in the industry. But regarding the civil engineering, UWB technology has some challenges. And now, there is no study on using UWB to monitor structural deformations. As we talked, it is very hard to find the real first peak in the received UWB signals. And the accuracy of distance measurement is about 10 centimeters. That is not suitable for many civil engineering applications. The low accuracy is caused by many reasons, such as UWB hardware, obstruction between the two sensors, and so on. And our contribution is bringing the UWB technology to the deformation monitoring in the civil engineering. So we must improve the accuracy. How to do it? We use a machine learning model and some error mitigation algorithms to help the UWB technology. Okay, our proposed measurement system is shown in the left figure. We have two UWB sensors, and we have a cloud server or a PC to collect and handle the received signals. The accuracy improvement methods are shown in the right figure. First, the UWB sensors collect the received signals. Second, the characteristics of the signals are attracted and used to train the machine learning model. Then, the errors of the machine learning model are reduced by two algorithms. Finally, bridge deformation is obtained. We use XGBoost machine learning model based on decision trees because it supports parallelized tree building and has many other advantages. The calculation only less than 1 second to handle a huge raw data use a normal computer. Regarding the two error mitigation algorithms, the first method is use low-pass filter to reduce noise in the signals. We compared different types of filters and select a moving average filter because the moving average filter showed the best performance. Just shown in this figure. The second method is to use a polynomial equation to reduce the bias errors caused by the machine learning model. We can see at the head and the foot of the deformation range, there are some bias errors. The polynomial equation can reduce the bias errors. It can let the prediction values moving from here to here, moving from here to here. It is closer to the black line. The black line is the true value. Our method has been validated through a field test. A concrete highway bridge in operation was tested under trucks in multiple loading cases. 5 trucks were used to load the bridge at different positions of the bridge. The whole loading test took 40 minutes. With a sampling frequency of 100 Hz, the UWB sensor collected 240,000 data. As we talked, two UWB sensors were used to measure the deflection of the bridge girder. One sensor was fixed on the ground, and the other one was installed at the bottom of the bridge girder. In addition to the UWB sensor, a dial indicator was used to measure the bridge deflection for comparison with the UWB sensor data. This is the test result. The blue line shows the continuous measurement result from the UWB sensors. The red dots here and here indicate the results from the dial indicator. If we compared the two measurement methods, here and here, we can find the maximum error was 0.95 millimeters. Okay, based on the above research, the following conclusions can be drawn. The proposed framework is proven effective in monitoring bridge deformations. The proposed algorithms improve the accuracy from centimeters to the millimeters. The frequency was 100 Hz. In the future, the performance of our method should be evaluated using more tests, and I think our method is a very useful tool to help engineers to monitor the bridge deformation and enhance the bridge resilience. That is all my presentation. Thank you for your attention. I would be happy to answer your question. Thank you.
What was the maximum error without correction filter?
Okay, this is a very important thing about the real-life applications. So if we don't use the signal processing techniques such as machine learning and the another new algorithm, then the error could be several centimeters. We found this in the literature, and in our application, we also did this measurement and got similar results. So in terms of the specific value, this was affected by many factors in application, but there's a range. It's about several centimeters or even more than 10 centimeters, which could be reasonable in some applications. For example, in transportation, some use cases might be acceptable, but for the some deformation monitoring of structures, that could be too large. So this is one of the main objectives why we proposed this study.
Is the base station affected by ground vibration?
Oh yes. Currently we haven't considered the ground vibrations, but indeed this is an important factor to consider. I envision there is a way to compensate that if we can, if we have a vibrometer to capture the ground vibrations. I think there is a way to account for that, but we haven't done this yet. This is a very good point, so we will consider that in our future study. Okay, there's another question about what is the accuracy of the dial gauge or indicator. In this case, I don't remember the exact number. In one of the slides, I think it showed the dial indicator. The accuracy is comparable to the normal caliber. I think it's a thousandths of millimeter, or maybe hundreds of millimeter.
Okay, thank you, Yiming and Yibao. Great presentation.
Thank you very much, and I appreciate the questions and this opportunity. Have a good day.
You too.
Thank you.
The third presentation this morning is titled Coming Soon, NJDOT Flood Risk Visualization Tool, presented by Rutgers University, John Carnegie.
Good morning, everyone. Thank you so much for participating. I'm very happy to be here to tell you a bit about a new tool that we're developing for the Department of Transportation. And this work is being done in collaboration with several units at Rutgers, and also with some input and work done by researchers at Rowan. The work is also being done to leverage funding from the Region 2 University Transportation Center that's run by Kate here at Rutgers. So truly a collaborative effort. My presentation today is going to start with a bit of background and context. I'll provide an overview of the project, kind of give you a quick update on and a preview of where things stand to date in terms of tool development and some other activities, and then tell you what's coming in the sort of fall, winter, and into next year. So just to start with a little background, I always find these graphics prepared by NOAA really telling and important to think about when we're thinking about why resilience is important, especially to the transportation sector. This happens to be the image for 2020 showing the number of billion-dollar weather and climate disasters that have occurred so far this year. There happen to have been a total of 16 events in the first 9 months of this year. 2020 is the 6th consecutive year, starting in 2015, in which we've had 10 or more billion-dollar weather or climate-related disaster events in the US. Since 1980, there have been 10 years with 10 or more separate billion-dollar disaster events, and 9 of those have happened since 2008. So the context of why resilience is important to transportation agencies around the country is both because climate and weather events seem to be changing, and the effects of those events on transportation infrastructure make it really important for us to think about how we can ensure that the infrastructure we have remains resilient, sustainable, and functioning during and after disasters. So because of that importance, the federal agencies sort of across the federal government have been working with state and local governments around the country to think about the importance of resilience, and in particular, the Federal Highway Administration has undertaken a significant effort really to help state DOTs and metropolitan planning organizations around the country assess their vulnerabilities, consider how resilience in transportation fits into the transportation planning process, how agencies can incorporate resilience in asset management, how we all can address resilience in project development and design, and how we can optimize our operations and maintenance practices to address things related to resilience. And certainly agencies in New Jersey, including the state DOT and our metropolitan planning organizations, have been participating over the years in efforts to increase the resilience of New Jersey's transportation infrastructure. In particular, the NJDOT over the last couple of years, and in particular the last 2 years, has been making a concerted effort to establish a comprehensive and enterprise-wide resilience program throughout all the departments. They have created a resilience working group that has several advisory groups to it, and they're also participating actively on what was created by executive order, the Governor's Interagency Council on Climate Change, which includes and is being led by DEP, but also includes representatives from all of the state agencies. The work that NJDOT has been undertaking over the past couple of years has sort of led to the work program that they're pursuing now, which includes the development of a resilience policy statement, the development of a framework for assessing vulnerability of transportation assets and infrastructure. They have been working with consultant Dewberry, who's the lead on much of the resilience work, to develop a criticality tool and framework for thinking about and assessing the criticality of various bridges, roadway, and other infrastructure. And concurrent with that, we've been working over the last 9 months or so to help NJDOT incorporate early in the project development process consideration of flood risk in particular, but also some other climate, more recently some other climate threats as well. And that work, along with the work that Dewberry is doing, will be informing some changes to the project development activities that NJDOT undertakes to include consideration of resilience, and we're working on new procedures for them. All of that work is being done collaboratively with the Resilience Working Group, as well as some sort of subgroups to that larger entity. I think we had the last meeting we had, there were nearly 100 participants from across the department in the meeting. So it is indeed something that has been embraced really from the leadership as well as the ground up. So the flood risk visualization tool was conceived through various conversations with Elkins Green from the Bureau of Environmental Analysis and at DOT. And the purpose really was to create a tool, which we've made a GIS-based visualization tool to map exposure to weather and climate hazards, including the kind of latest science, incorporating the latest science on how the climate may affect precipitation in particular, but also temperature and some other things. So that will involve developing methodologies for mapping and visualizing inland and coastal flooding from both rain events as well as storm surge and sea level rise. Some of you may be familiar with the New Jersey Flood Mapper tool, which includes right now visualization capability for the coastal counties, the coastal zone areas. So that data and information is being brought into this tool, which will be internal to NJDOT and available to personnel in all of their departments. And then we're going to be incorporating, in addition to that, inland flood risk, both current and future, for all of the remaining watershed areas in New Jersey. So it'll be statewide coverage, and including also layers for heavy precipitation and extreme weather as independent threats that may also affect project design, operations, maintenance decisions, things like that. One of the tools that we're putting together as part of the overall visualization framework is a Zoom 2 widget, which will be tied to the department's straight line diagram database. And the user will be able to select a particular highway as well as a particular milepost or milepost range to zero in on the infrastructure asset that's of interest. And we'll also be integrating the DOT's bridge database information so that that the users can also zoom to a particular bridge using a bridge identification number. And then finally, all of this work is intended to be integrated within existing workflows within DOT, not hopefully creating new activities or workflows, but modifying existing workflows to help DOT incorporate the data from the mapping tool in transportation planning decisions, project development decisions, and decisions about operations maintenance. So the first phase of this project really is a sort of a fact-finding piece, as well as developing the first iteration of the tool. So we're working to understand what the data needs are of DOT personnel at different, responsible for different aspects of transportation decision-making, both at the manager level and the end user level. So we've been engaging with select groups of folks to understand those workflow and data needs, as well as to get input about what the tool interface and functionality should include. We're hoping that by the end of this year, we will have a tool that is deployable, that will allow DOT personnel to flag potentially exposed properties infrastructure and assets, both in coastal and inland areas. And we're imagining the rollout of the flooding related data layers in a sort of stepwise process. So initially, kind of proof of concept, we're using the FEMA flood hazard maps and operationalizing those along with the straight line diagram database Zoom 2 tool, so that initially personnel will be able to identify areas in flood zones. And then I'll tell you in a minute about phase 2, where we're going to be enhancing that flood data to include some new modeling that will be available from a couple of different sources. So we hope to have the version 1 of the tool available in December of this year. And then phase 2 will be adding some additional storm-specific flood scenarios. Some of you may be familiar with the Resilient New Jersey initiative that NJDEP has been advancing. And that initiative included some HECRAS flood modeling for the coastal counties, and DOT has been investing in advancing similar modeling to include a statewide data coverage. Listed on the screen here are some of the scenarios that were used to create the data layer. So there'll be 4 future scenarios and then 2 kind of existing scenarios that are storm-based, like 2-hour storm and 24-hour storm. In addition to that, we'll be developing a sort of more flexible way of thinking about flood risk in a kind of total water level context. And that work will be informed by a technical advisory committee of experts from universities and other agencies to help us work through a series of questions to understand what the best approaches are and what the best assumptions should be for future climate risk. The visualization ultimately will include the ability to look at the coastal zone as well as riverine and we hope riverine and storm surge combined flood risk in tidal river basins. And that tool, the sort of second iteration of the tool, version 2.0, should be available in the middle part of next year. So results and outcomes to date, we've been able to develop a prototype for version 1.0. Includes the ability to include some reference boundaries like county and municipal boundaries, as well as the NJDOT tool panel that is keyed to the roadway network through the straight line diagram, as well as the bridge location database and data related to each of the bridges. As I said, we'll have the zoom to mile marker selection functionality, and the flood hazards will include total water level, sea level rise, sandy surge, and slosh category 1 to 4 storms for the coastal zone. That's the data that's currently available in New Jersey Flood Mapper, but not in a way that's tied to the transportation infrastructure. And then also the FEMA flood zones. We recently have sort of been exploring with the department. I think that this will probably be included. The data layers that I mentioned before, precipitation and temperature, as climate hazard data layers that are currently available at through some Rutgers and others university research sources. So we're going to be bringing that in and exploring how that data can be informative to the project development process as well. This is just I've got to run through a couple of screenshots of the prototype. So on the left is the main tools panel. That's where you will access sort of pop-up windows for the DOT tool panel, the boundaries, climate hazards, flood hazards, etc. The search window appears here under the NJDOT tool panel, and then you have legend controls. This is very similar to the interface already available through New Jersey Flood Mapper and other similar tools that are built off of ESRI, ArcGIS online platforms. The flood hazard panel will include a series of choices that you can make to visualize in different ways the different flood risks. This happens to be in the coastal area. I've selected Atlantic City Expressway here, so you can see a series of dots which represent mileposts. Each of those has data associated with them. You can hover over those and pick up the data. And then the dark blue mapping element is actually the extent of sandy surge during the Superstorm Sandy event. And then finally, there'll be this layer related to other climate hazards, including changes in temperature and precipitation. So we've engaged with an internal workflows kind of working group that had 24 participants. We were asking them to sort of basic questions about how they think this type of data would be incorporated in the project development process, kind of what assets and infrastructure are of interest, and in addition to bridges and roads. Some items that came up included signals and ITS, et cetera. And then what kind of information is useful to inform the reporting and things that need to be done as part of the project development process. Outcomes included, it will indeed be useful to flag potential exposure to flooding. However, also important is understanding the criticality of a particular asset or a piece of infrastructure. So if, especially in the context of AADT, if a road is not significantly traveled and it's subject to flooding, that's different than a road that carries 100,000 vehicles a day that's subject to flooding. So understanding criticality in addition to exposure in the same context is important. So we'll be kind of working with the Dewberry team to figure out the best way to bring in the data from their criticality tool with the climate risk flood or the climate risk visualization tool that we're developing. Also, outcome included that that for the level of detail that we're providing in terms of looking at exposure to flood risk and other climate hazards, the problem screening process is probably the best place for that. However, noting that it's also important to include flood risk data in the concept development phase. So I'll tell you in a few minutes what we're thinking about recommending in terms of how to include the data from the tool in the problem screening phase. We also heard that that it might be appropriate to include additional asset and infrastructure items such as signals and ITS. I mentioned that before. So we're engaging further with the Transportation Operations Systems and Support Group within DOT to get their input. And we also heard that it would be very useful to coordinate the flood exposure data with data and outputs from the drainage management system that DOT maintains. And we've had a follow-up meeting with the drainage management system team, and we'll be figuring out how to perhaps create some complementary, some ways to complement and create some synergy between those two databases. This is the kind of working ideas related to the problem screening process. So there are existing steps. The problem screening process is indicated over to the right in terms of the graphic image. So there are some existing steps in that process where it seems appropriate to include a new kind of data protocol for including resilience-related data in the initial data collection activities that happen when DOT staff are reaching out to the various management system folks to incorporate management system data. Seems like it's appropriate for the folks putting together the problem screening reports to be engaging with the Bureau of Environmental Resources as subject matter experts, and probably the ones that will be most using the flood risk visualization tool, and then a new section in the problem screening report that covers the data and reports the data. I mentioned the technical advisory committee. I'm not going to go into much detail here. We're shooting for late November, early December meeting. We'll include probably about 20 or so, 15, 20 experts from academic agencies or academic institutions, federal agencies, state agencies, et cetera. We're going to be talking about the latest and greatest in the bumps and the warts of various flood modeling methods and techniques, what we currently know about precipitation and what other assumptions and values we might need to include to come up with accurate flood depictions and predictions, and then short and longer term approaches to address in particular the combined storm surge and river flow flooding in tidal river basins. So that's the sort of additional and ongoing engagement and outreach with DOT staff and subject matter experts, and getting some real time input from end users with our prototype will happen this fall. We'll be convening that technical advisory committee and hopefully having a tool to deploy by the end of the year with a user's manual and some training. I'm happy to answer any questions that people might have right now.
There are quite a few in the chat box right now. Start at the towards the beginning on the group them together. Is the app available? Is the tools available for major county roads?
Whatever's in the straight line diagram is our database right now for the roads. So I believe that includes 500 and 600 series roads. Those will not be tied to mileposts because there is no milepost data for them.
Include roadbed elevations to determine whether flood stages would be above road beds, similar for bridges.
Yeah, so that's one of the vexing questions of internal databases that we have available to us. They do not, most of them do not include, or at least there's not a centralized source kind of statewide for roadbed elevation and top of bridge deck elevation. However, we're exploring different ways of using LiDAR data to estimate what those would be and incorporating that in inundation modeling and mapping protocol.
Does it incorporate multi-event scenarios?
So this is really, it's an exposure visualization tool. It isn't an analytical tool that would allow you to consider the combined effects at the exact same time. However, you can use the tool to look at, if there was a precipitation event and if there was a coastal storm at the same time. We're hoping that we'll have a layer that can show what the combined effects would be in tidal river basins, but it isn't really a scenario planning tool necessary. It's really serving up data related to specific risks in the context of specific infrastructure.
Will you investigate how the interaction between fluvial and riverian water flows will interact with estuarine and coastal water sources, such as what will be the exposure and hazards along the Raritan Bay, Newark Bay, etc., due to hurricanes, where you have coastal flooding and rising tide, storm surge, and river flow with rainfall?
So I've mentioned a couple times we hope to have a protocol that includes the combined effects of fluvial and coastal inundation, that includes storm surge and perhaps sea level rise combinations. Our plan is to discuss this with the expert advisory panel, and we think that there will probably be a short-term approach and then a longer-term approach. So obviously this particular project is constrained by time, budget, available data, that kind of thing. So what we anticipate doing is saying, given those constraints, what's the best thing we can do right now to help to understand what that combined effect will be? And then in addition to that, saying, if we had more resources available, more money, more time, greater data, what would an improved approach be? And that could be a sort of target for the future if it seems like that's something that the department or other state agencies want to pursue either individually or collaboratively.
Can the data from the tool be exported to GIS shape files?
Yes, so the tool will have map services associated with it. So pretty much any of and we'll certainly be providing all the data that is being ingested and used in the internet-based tool to the GIS folks at DOT. So all the data layers will be available for use and manipulation in an external GIS environment.
Okay, thank you, John. Great job. Really go well. We are now moving on to the fourth presentation, NJDOT Environment Resilience Presentation, presented by New Jersey Department of Environmental Protection Assistant Commissioner Dave Rosenblatt.
Good morning, all. I am Dave Rosenblatt, Assistant Commissioner for Climate and Flood Resilience. I'm also the state's first Chief Resilience Officer. Last year, about this time, Governor Murphy signed Executive Order 89, which required of the department the development of several products. The first was the scientific report on climate change, the Coastal Resilience Plan, and the statewide climate resilience strategy. Those efforts that are under me are circled in orange. All the other circles are activities related to greenhouse gas mitigation, other types of resilience. And the purpose of this slide is to show you just how active the department is trying to reach the goals for greenhouse gas emissions and also adapting the state to the changes that climate change is going to bring. All right, so we did not have to start from zero. We were fortunate enough to have a relationship with Rutgers, who prepared two documents for us, very important as we started out evaluating climate change adaptation. One was this overview of state coastal zone management policies designed to promote coastal resilience. What were other states doing? We all had the same problem. If you're along the ocean or Pacific coast, or even the Bay, Gulf of Mexico, we're all going to be dealing with increased storm frequencies, increased storm intensities, increased sea level rise rates. So what were they doing? And this was a very valuable tool for us. Likewise, in November of 2019, Rutgers published the report of the 2019 Science and Technical Advisory Panel. This was about sea level rise. And what was great about this report, it was very specific to New Jersey. Again, we are not the only state that have to deal with these issues. We had reports available to us from Texas, from Louisiana, from Rhode Island, and various cities have also been working on resilience plans. We really like the Resilient Roadie product from Rhode Island. It is looking at what they're doing, what they have been doing, and where they want to go in a variety of ways, in legislation and projects, et cetera. Texas and Louisiana plans were more civil works project oriented, which is fine to deal with the problems they have. Of course, they're going to be very civil works minded. And most interesting to me was the product from Miami. They focused on the resilience of their communities, the protection of the diversity that makes Miami so unique, but mostly keeping those communities together by protecting them. A great report, and we can make use of all these as models. All right. So one of the first things Executive Order 89 asked us to do was to put together an Interagency Council on Climate Resilience. And we did that. 17 agencies are participating on the council. The idea here is we want to share with state departments the science that DEP has been focused on regarding climate change. And frankly, we want the agencies to share with us what their understanding of is climate change and how it's going to impact their programs and how they intend to respond. By putting us all together, we're more likely not to duplicate efforts, that we'll be more efficient in the expenditure of resources when it comes to providing for grants for new research. So this is a key first step for us. All right, as I said, one of the products that we had to prepare was the scientific report on climate change, and we did that. It's on our website. It was released June 30th of 2020. It was our effort to put the climate change science as we know it, as it's going to impact New Jersey, in one place. It's a tremendous 200-page plus document, which is supported by a 10-page executive summary, which is very easy to read. It brings out the highlights of the report. And we feel that this is a product, this is a document that needs to be shared with the public. So the executive summary is written with the public in mind. The full report, yes, the public can read it, but it's really meant for people to want to drill down into the details of what we expect the changes to be. I will point out that the science report is going to be the basis for everything we do. It is the first iteration of the report. We expect this to be continually added to because we expect more data regarding climate change to be developed, and we want to make sure that our product that faces to the public is up to date and provides them the best information to make their decisions with. Now, the key items here, of course, are temperature and precipitation. We see temperature increases already since 1895. We expect further increases of 4.1 to 5.7 degrees Fahrenheit by 2050. We expect annual precipitation to increase, and we expect intensity and frequency of precipitation events to increase also. I'm going to show you in a second, I'm going to show you sea level rise data from the sea level rise report records. And I can say that we are much more assured of the sea level rise data than we are of rainfall. Rainfall is a little bit more squirrely. The projections are a little more squirrely than the sea level rise projections are. But nonetheless, we are confident that we'll see increased precipitation frequencies and intensities. And as a running commentary, I see somebody was looking for a link to the scientific report. Go to the department's website, and I think it's becomes very apparent how to find the science report. It's there. It's free. Read it. It's good. All right. So out of the sea level rise report came this cornerstone or keystone chart. I don't want to spend too much time on it, only to say that we have decided to be looking at the time frame of 2100 as we begin to develop our regulations, our rules, our policies. And the reason for that is, yes, it's a long way off, but the things that we're building, whether it's developments, homes, infrastructure, we do expect them to be around in 2100. So we want to at least be mindful of what the future looks like and what it will bring, and therefore we have to look far out into the future. Looking at this chart, we also decided that we were not comfortable resting with a 50% chance that sea level rise will meet or exceed a certain number by any of these years. We decided that we'd be looking at sea level rise that there may be only a 17% chance that it be met or exceeded. 17% chance that sea level rise will be at 5 feet by 2100. That's what we're zeroing in on right now. All right, these are some of the highlights, some of the chapters from the scientific report. Again, I think it's especially well laid out and brings out the highlights of what we know. Before COVID, we had planned to have 6 regional meetings in the state to make sure we reached out to as many municipal officials and stakeholders and interested public parties as we could in order to not just give them information as to where we think we are with climate change, but also to bring in information as to where they are with their understanding of climate change. We had, in place of the 6 regional meetings, one large webinar where we took in information, of course, and we did this primarily through a survey that we did. Out of the 350 people that participated on the webinar, we had about 160 or so returns of our survey. And what we found very interesting, I'm not sure, it's kind of small on this screen that I'm looking at, but if you look at this, the box on the right, you'll see where most of the people fell out when looking at how we were to approach climate change or adapt to climate change in the future. More often than not, people did not want us to pursue major civil works projects, maybe because they're afraid of taxes increasing, or maybe they just realized that we probably have to go a different way when we're talking about adaptation to, say, sea level rise or increased flooding. Of course, there will be some civil works projects into the future, but really, they want us to look at other opportunities, whether it's green infrastructure or policies that just move populations to safer areas. So we certainly appreciated this input, and will be proceeding with these preferences in mind. Okay, so one of the major products Executive Order 89, Governor Murphy asked us to produce was a climate change resilience strategy for New Jersey. We're looking at a product in 4 parts. First introduction, the climate change in New Jersey will be a very cursory summary of the scientific report. And then the 2 key components here, the strategy section, responding to climate change, and the coastal resilience plan, which will be a standalone document because of its size and scope. Now, this is just a blow up of the strategy section and the different strategy sets that we are developing now. And let me point out again that we're developing this with the Interagency Council, not just within DEP. So we're going to have a very wide-ranging scope of strategy sets. And I'm not going to read each one of these to you because I'm going to get to them in a second, but 1 through 5, and then of course, if you look up top, you'll see the standalone coastal resilience plan. All right, so strategy set 1, supporting and sharing the science. This is, thank you, Ted, for the link. This is really so critical. Supporting the science, whether through Rutgers or NJDOT or Rowan, who have all asked to play a role in the future science development and are playing roles. But beyond getting the science, supporting the science is sharing the science. And who are we going to share it with? Well, it's important that not just agencies, whether at the state level or the county level, local level, get the information, but also the public. The science has to be presented to the public. The science has to be presented to the public. And when I say public, I do mean all the public, even people that don't historically pay attention to the science that we have presented in the past. We need to make sure they can understand it. We present it in a fashion that they will. That's a major charge for us. All communities must understand what's going to happen over the next decades. And the reason they do, let me just add this, the reason they do is because they're the ones who are going to be making decisions at every level as to how tax money is going to be spent in order for this adaptation to occur. Now, strategy 2, the strategy set here, building resilient and healthy communities. I mean, this is a huge part of what we're trying to do, right? Protect communities, protect people. Not every action that we take is going to be taken at the state level, of course. We are going to be supporting a lot of county and local, regional actions as we move forward. But we do want to be in a position to advise the local levels, regional levels of government and community activism as to the best steps to take. And we're not going to forget, of course, about our ecosystems. We want to make them more resilient, protect them whatever way we can, reduce the stress that they're already feeling from pollution, overpopulation, reduce some of their stresses so they can respond themselves to resilience, to climate change. But we also want them to be resilient because of the protection they offer us. So when I say that, I'm thinking largely of coastal wetlands, freshwater wetlands. They do provide flood protection for our communities too. So dual purpose of the strategy set here. Oh, this is a big one. All these strategy sets are big, but promoting coordinated governance is important. We need to take a whole of government approach to climate change adaptation. It's going to have to be across the state level and permeate down to the lower levels and across the regional entities of government that we have. If we're going to get this done, we want to see equity, inclusion, and innovation being essential to the discussions that we have at the Interagency Council level and what we take to the local levels. But again, resources are limited. They always are, even more so now. We want to make sure that we're working in as coherent a fashion as we can. And I said before that resources, including financing, money, are limited at this point, and they will be. So what are the new ways that we can fund our activities, whether they're major projects or their public information campaigns? How are we going to do that in a very sort of effective, efficient manner? But we're going to have to look at new ways of funding it. It's not just going to be top down from the Treasury down to the local level. It's not always going to work like that. There's going to have to be some self-funding in communities, I believe, where parts of communities at least will need to figure out ways, and we can certainly help them, of providing adaptation projects for themselves. Throw that out there just as a preview of what we're expecting. It's not always going to come from the state. There's going to have to be some local funding of projects that are going to occur. And the Coastal Resilience Plan. The coast is so important. And it's not just the Atlantic coast, but the Raritan, Delaware Bays, and up into the Hudson. So our entire tidal area needs to be made more resilient, particularly to the effects of sea level rise. 5 feet of sea level rise by 2100 is responding to that is daunting, but I think that we have our ways of addressing this, and we will be developing new ways to get communities safer, sometimes out of harm's ways. But the Coastal Resilience Plan is going to be fairly extensive. All right, so we recognize the need to look at regional efforts, regional coordination. We had the New Jersey Frames project, which was our model as we move forward. New Jersey Frames was focused on the area of the Shrewsbury and Navesink rivers, bringing the towns together to talk about common issues, projects, things that would make a region more resilient. So we moved forward with a project called Resilient New Jersey that will be looking at 4 regions with multiple municipalities. We are funding engineering firms to work with the engineering and consulting firms to work with each of these regions. And we have just started. We've just got the contracts out there, and we're having initial meetings. We expect that we'll finalize the resilience planning by the spring of 2022. These projects will be, and I'm noticing now on the slide, we have a duplication of the Jersey City, Hoboken, Bayonne project area. And we're also looking, of course, where the purple is at another area, which is in Middlesex County, Perth Amboy area. And again, separate those out there. But we know that we're not going to be able to accomplish this municipality by municipality. Municipalities are going to have to work together for a common regional interest. My work with the Army Corps of Engineers, with our Coastal Engineering Division, we're expanding the efforts from looking at discrete areas to looking at much larger areas. It's something new for the Army Corps of Engineers. We're looking at the entire Back Bay area of the Atlantic coast. You've heard of the Back Bay study, I'm sure, comprehensive study. And we're looking at the New York, New Jersey harbor area. How do we stop flooding there? These are, when you look at huge areas like that, it's again, I'll use the word daunting, because what you come up with are lots of projects requiring lots of resources, lots of money. But it's a comprehensive way of dealing with what we're going to have to deal with climate change. So again, these will be models for our future plans, and we hope that well, we know we're going to get a good product out of this, but we're hoping that other cities, even before these products are done, will be looked at by other cities that want to start their own regional efforts and use these as models. Here we go. So I'm free to answer any questions. Thank you for listening.
We have time for one quick question, and it's how does different resilience plans under New Jersey DEP tie into New Jersey's Transportation Asset Management Plan?
Please repeat that again.
How does the different resilience plans under New Jersey DEP tie into New Jersey Transportation Asset Management Plans?
Yeah, I have not, as the Interagency Council, forget about me, the Interagency Council is not taking on that relationship yet. DOT is present, of course, on the Interagency Council, and I don't have a good answer for that. Certainly, it has to be tied in. DOT has to be at the table, coordinating with us, sharing the science, but I cannot answer that question at this point in time. It's a little too soon in the progress of the council.
Okay, thank you, Assistant Commissioner Rosenblatt. Our next presentation is the New Brunswick Innovation Hub Smart Mobility Testing Ground Phase 1 Planning Project, presented by Drs. Peter Jin and Ali Maher of Rutgers University.
Hello, everyone. I'm Peter Jin, an associate professor at Rutgers University. Today, we're going to present an effort that we have been planning since 2019. It's the New Brunswick Innovation Hub Smart Mobility Testing Ground Project. This is an idea proposed by Rutgers Kate, and we're in collaboration with NJDOT, Middlesex County, and the City of New Brunswick towards the deployment, along with our industrial partner Verizon and Iteris. In this project, we envision to respond to the future of transportation, the latest development coming from smart mobility technologies, self-driving technologies, as well as the improvement in information technologies, such as smart computing, big data, deep learning. So our vision for future is slightly different from the industry trying to depict to us that all the vehicles will be converted into self-driving cars. And the self-driving cars will dominate the entire traffic stream. We envision that still has yet to come, but at the meantime, our approach is to look at the roadside. How can we make the roadside infrastructure smarter, with more computing power, better sensing capability, similar to those already deployed in self-driving cars, and use those to enable the application access to a larger community, a larger pool of legacy vehicles. So the application can include vehicle-to-infrastructure applications, vehicle-to-vehicle applications, vehicle-to-pedestrian applications, and also all the cloud-based communication layer that enable all the applications from the cloud and the internet. This is the kind of showing up as three major tiers of test beds, testing grounds, test sites related to connected automated vehicle technologies. We start from the connected vehicle technologies deployment. This has been this is the technologies that has been widely explored around the country. There are many experimental sites deployed already, and for the purpose of enabling the information sharing between vehicle and vehicle, vehicle to infrastructure, as well as onboard units of vehicles. Through the US DOT ADS demonstration grant, there has been several development in establishing automated vehicle demonstration ground around the country. There are about 10 to 15 sites, including public and private sites, that was developed to dedicated to testing self-driving technologies. The proposed New Brunswick Innovation Hub is in a tier of its own, along with four other test sites focused on connected and automated vehicles. The two sites that we are different from the M-City in Michigan and the Soundtracks in Florida in terms of we are live testing ground. We are actually deployed in the field. We are different from the testing ground currently deployed in Nevada, Reno, and Georgia, Peachtree. Is that we are actually in a congested urban corridor. We have 10 times the actual traffic volume than the other two. And we are really in a northern region with a lot of severe weather conditions and very representative of the kind of some most challenging cases of self-driving. This idea is really coming from Governor Murphy's vision of creating the hub to promote innovative economy in central New Jersey. We have been working with different agencies. We were one of the 9 communities in collaboration with the city of New Brunswick. We're one of the 9 communities that won the NJDOT New Jersey Economic Development Authority inaugural innovation challenge in 2019. From there, we won a planning grant from where we have dedicated resources and talents towards building up the testing ground concept. We have been in communication with NJDOT and Middlesex County towards planning, design, and detailed implementation plan and potential funding for 2 different phases of this project. The main concept of the proposed testing ground lies in 4 major pillars. The first one, as I mentioned before, is to look at how can we bring the self-driving grade roadside sensing and computing infrastructure out of those self-driving cars, but to the roadside, and then use that to serve all the traffic that coming through for example, a corridor like Highway 18. And this is to look at how these data can be collected and then feed back to all those vehicles so that they can take benefits of these new technologies, even without upgrading to a full-blown self-driving cars. With that roadside sensing capability in high resolution and high performance computing, we're also looking to really accumulate smart mobility, industrial grade smart mobility data that can be used to support R&D, especially to contribute to the data that's needed to calibrate and fine tune all those self-driving models, which 70% of them are still relying on synthetic data. Mobility technology testing a breeding ground is also one of the goals for this testing ground. We want the data and test platform to become available to test all kinds of technologies at different stages. The last one is not the least, is to look at the commitment to communities, really to develop smartphone-based community mobility applications that can allow local residents and commuters to take advantage of the data services and application services provided by the testing ground. The proposed testing ground is what we call a living lab. So it's a lab that was supported by technologies, but enable different ways of conducting research and development in a live environment. At the core, we have high-resolution sensing technologies through LiDAR, through high-resolution cameras. And we also have DSRC 5G communication that's enabling different level of connected vehicle applications. We have the edge and cloud computing that essentially addressing the computing infrastructure needed to support both on-road and central analytics. We also have this 3D modeling and digital twin platform technologies that was used to essentially creating virtual environments that can allow proof of concept, really academic exploration or early stage R&D to happen in a safe environment using the digital twin platform. The last but not the least is a smartphone application and onboard technologies that can be used to build up applications that can serve the communities and allows them to participate in all kinds of testing. The Smart Mobility Testing Lab, it will include the R&D platform to support self-driving and smart mobility technologies. to promote data sharing among different sectors and also with the road users. But also creating this data hub to support the R&D at different sectors and providing the test platform for new smart mobility applications. The proposed project will include two major phases. The phase one is in collaboration with NJDOT towards really deploying the smart roadside sensors, roadside units onto state highways on routes 18 and 27. We'll comprehensively will create a data and computing center towards supporting the testing ground, and then conduct some preliminary autonomous shuttle testing and CV application testing. In phase two, in collaboration with Middlesex County, City of New Brunswick, is to look at expanding this testing ground towards county and local street to create this full multi-jurisdiction testing ground for different applications. Furthermore, we will be extending the data hub towards a more comprehensive futuristic mobility management center and creating the R&D mobility data hub towards serving kind of potential revenue sources to support and sustain the testing ground. The last one is on the testing side. We will further work with industry partners to look at testing of other technologies, other self-driving technology, including autonomous car, autonomous truck, and other community mobility applications through connecting automated vehicle instrumentation. The proposed system architecture includes multiple layers, includes a traveler interface, various type of sensors, the different computing devices from edge to fork to central computing, so different level of data hub, agency support at different, various type of applications, including safety, mobility, and environment. Finally, the living lab component, creating the data and testing platform towards technology transfer, and also creating, using the proposed, for example, the digital twin model to enable virtual reality, AR, VR-based, or the cave-based workforce training towards a new smart city and smart mobility technologies. This is a kind of the geographic scope of the proposed testing ground. It includes what we call the East Wing, essentially our state highway, Route 27, Route 18, and also the West Wing is mostly county roads and local roads, including some hospital routes and campus bus routes. We are looking at this is giving some of the detailed roadside instrumentation design that includes from the top, the cameras, the LiDAR sensors, the edge compute, radar sensors if needed to provide redundancy. There are different ways of installing the proposed instrumentation, looking at install at light poles and signal poles, install at freeway gantries. And also we're working with Iteris and Verizon to identify locations that we can put rooftop cameras towards collecting traffic data with much less occlusion. This is a proposed some of the proposed routes on the for the county wing for the West Wing, the county and local routes. One of that we propose is to look at how can we connect the two medical central campus, St. Peter's and Robert Johnson Hospital, through autonomous shuttle by providing better accessibility for the local communities and people traveling from the transit stations. The other aspects is to experiment with connecting automated vehicle applications towards using the smart roadside units to enable different V2V, V2I, V2P services, and also working with different levels of autonomous vehicles to enable future self-driving. This is a kind of the proposed mobility data hub and digital twin model. We're looking to really using LiDAR sensor technology, both infrastructure scanning and also this data collection of the dynamic vehicle trajectories, pedestrian trajectories, and then reconstruct the dynamics in live in a digital twin, digital sibling of the entire testing grounds. And this will create a virtual environment that's safe to test all kinds of application at the early stage, and also providing a powerful visualization environment towards inspecting traffic conditions, technologies at different aspects. We can essentially replicate any visual angle, visual perspective through this digital twin framework to simulate what view can be seen by different technologies. We will also be building the smart mobile community mobility applications to allow to collect video data and sensor data that can be used to calibrate the digital twin model. Over the pandemic, we actually worked with two sensor company, Velodyne and Ouster, to really look at how the latest high-resolution sensing technology fare when we use them as a roadside sensor. And we find some interesting results. Of course, the top-of-line instrument is Alpha Prime from Velodyne with 500 feet tracking range. But the Ouster is 1/3 of the price of the Velodyne, and it can also achieve about 300 feet tracking. We have been, the entire project team will be a multi-sector collaboration. We are working with our public sector partners and private sector partners towards this entire planning process. We also was able to outreach to many academic sector partners, researchers around the world, around the country, and many of them are showing high interest in potential collaboration and using the data from the testing ground. In New Jersey area, we will be creating this related academic alliance related to using the testing ground and using the data from the testing ground for research innovation. From Rutgers side, Rutgers Kate, myself, Peter, Dr. Maher, Dr. Jafari will be the PIs, and John Carnegie from Voorhees Transportation Center will be the co-PI. We will also be working with WinLab cosmic projects towards really sharing resources and potential collaboration on data and digital twin modeling. We are also interested in collaborating with NJIT's IT Resource Center to work together with their share experience with their deployment at Smart and Connected Corridor in Newark. We will work with Stevens Institute of Technology to potentially work with the broader national self-driving communities, which similar to events hosted with the PennDOT. We'll work with Rowan, TCNJ, Columbia through different aspects of the application development for the testing ground. We'll try to work with Smart Driving Car Alliance and Princeton University towards enabling access for all concept testing. We will have been in contact with M-City, Soundtracks, and Carnegie Mellon testing facilities towards building a potential corridor of self-driving corridor of enabling various testing at different geographical areas in the U.S. This effort also aligns well with the Middlesex County Destination 2040 strategic plan, in part of trying to establish local leadership and creating high-tech jobs and attracting investment and creating this ecosystem entrepreneurship. We really want to tie this back to the contribution to the potential state impact. To say this is not a pure academic effort development, but really has the potential to contribute to workforce development, contribute to technology breeding, and also contribute to the local economy, innovative economy with data access and all these technology enablers in our testing ground. Some of the goals that we want to achieve is to use this high-tech innovative economy to bring on the spillover effect to create even larger economy benefits in this area. This is the presentation. This is an ongoing effort in collaboration with NJDOT and Middlesex County. We look forward to have further discussion with anyone who's interested in using our platform, contributing to the development of our platform, or interested in data sets that will be produced by the testing ground.
At this time, we'll have some questions, and there are already a few here in the chat box. What are the safety elements that you will be able to capture with the equipment along Route 18 and 27 and county roads, such as wrong-way driving?
Yes, that's a great question. Actually, during the planning process, we work with NJDOT's requested data from them to take specific looking at some of the very typical crashes at the intersections and merge sections. We did identify several important types: side swiping, some intersection crashes, and several hotspot locations in this area. And the data that's collected from the high resolution sensors will have the capability of identifying potential conflicts, identifying hot zones. So we're working currently with both ITers from the industry and also several researchers in New Jersey area to look at what are the potential application, including Dr. Jafari from Kate and also Dr. Jalea from Rowan University. So this is an emergent data set that has been used to evaluate near misses and hotspots in in some recent research, and we hope to bring that to bring that element to this testing ground to promote safety.
Next question. What is the penetration of the OBUs for the vehicles, and what are the plans to increase the penetration?
Yes, that is a great question related to connected vehicle technologies. That's a major limitation for many of the existing test beds of CVs to really function well. The individual vehicle in order to make their resources functioning. This is different in this testing ground because we have the high resolution sensors on the roadside. Our approach will become, we will collect all this data and even generate BSS TM messages for vehicles and pedestrians that are not even participating in this network. We will still be able to see them and generate safety messages related to their trajectories, and any services and any users that will be participating in the system will be able to use the data set to use all the CV applications that will be tested. So this is a slightly different approach that doesn't rely on penetration to OBU to create a full application suite. But at the same time, it's very open to any different applications to participate.
And the final question is, can you use laser traffic technology at intersections?
Laser traffic technologies. Maybe clarify a little bit, what is a laser traffic technology?
They didn't say it. I'm wondering if they were talking LiDAR. But...
yes, this is actually going to be using LiDAR. We have conducted experiments of using LiDAR at several intersections, and they generally collect the traffic data, the vehicle trajectory data very well, and also provides detailed information about the shapes and types, and are weatherproof and work day and night. So this is definitely in play in terms of enabling testing of intersection-based applications.
Okay, thank you, Dr. Jin.
Thank you.
We will now move into the second part of our virtual poster session. Please use the chat pod for questions. The poster presenters will have an opportunity to respond at the conclusion of the 3 presentations. Our first poster presentation is titled Utilization of Hybrid Fiber Reinforced High Performance Concrete for Control of Shrinkage Cracking in Bridge Decks. and is being presented by Rutgers University's Mohammed Abed.
Hello all, I'm Dr. Abed, a postdoctoral associate under the supervision of Professor Hani Nassif, where I'm a part of RIME group. I will be discussing the topic of control of shrinkage cracks in bridge decks by using hybrid fiber reinforced high performance concrete on behalf of our team, but mainly on behalf of Mina Habib, who is a former graduate student. It's well known that concrete bridge decks are very oversensitive to transverse shrinkage cracks. And one of the proposed solutions to minimize the shrinkage cracking on bridge decks is to introduce macro polypropylene fiber in high-performance concrete. The team implemented the fiber high-performance concrete mix at the concentration of 5 pounds per cubic yard of fiber to one of the major highways in New Jersey. This implementation was completed successfully and reduced the frequency of transverse cracking by around 33%. However, the cracking frequency could be improved further by implementing a combination of different types of fiber into the mix design. For instance, using micro and macro polypropylene fibers together could influence the cracking process at the different stages of loading. The implementation of the hybridization fiber is one of the latest remarkable developments in fiber-reinforced concrete for developing a concrete with more attractive engineering properties. Thus, the main objective of this study is to evaluate the performance of hybrid fiber-reinforced high-performance concrete on shrinkage and cracking resistance with combining steel prime fiber, macro polypropylene fiber, and micro polypropylene fiber at different fiber volume fractions. 8 mixes were produced with a constant water-to-binder ratio. Of these 8, a reference mix without any kind of fibers, 2 mixes with single type of fiber, and 5 hybrid mixes. It's good mentioning before following to the result that Ashtor ring test was the primary test which utilized to measure cracking frequency properties. Firstly, the mechanical performance of hybrid fiber reinforced high-performance concrete was investigated, and the results were as follows. Compressive strength improved at early ages, but this improvement became less pronounced at later ages. Tensile strength increased by up to 18.6% by using macro and micro hybrid fiber, where they provide together a synergy in the matrix. Modulus of rupture increased by around 24.5% by using steel and macro polypropylene fibers. Free shrinkage is reduced, where the microfibers tend to reduce volume changes. Regarding restraint shrinkage test, hybrid of steel and macro polypropylene fibers help reducing the number of cracks, and hybrid of macro and micro polypropylene fibers help reducing the crack width by up to 33%. In conclusion, it's proven that the applying of the concept of the hybridization of fiber in high-performance concrete enhances the mechanical performance and cracking resistance of concrete. However, other combination of hybrid fiber in high-performance concrete needs more investigations. This project is funded by the New Jersey Turnpike Authority, and the authors thank to Bill Wilson and Frank Corso for their financial and technical support. Thank you for your kind attention.
Our second poster presentation is Load Rating and Load Posting Policy of Bridges for SHVs and EVs. The project is being presented by Chan Yang of Rutgers University.
The poster presents the study of the load rating and posting policy for the special hauling vehicles and emergency vehicles, as well as the reliability assessment for the special hauling vehicle load models. And here are some backgrounds. In 2013 and 2015, the Federal Highway Administration published 2 memorandums to require all the state agencies to rate their bridges for the SHVs and EVs. And both 2 trucks are specially configured, so they can result in a high load effect, which can adversely impact the bridge rating factors. And the load models for the SHVs and EVs were developed accordingly, as shown in the figures. For the SHVs, the SU4 to SU7s were developed, and for the EVs, the EV2 and EV3 were developed. Given the backgrounds, the objectives of the study is to Firstly, develop recommendations for the New Jersey DOT on the load posting policies for the SHVs and EVs. And secondly, to quantify the SHVs and EVs that are actually traversing on the New Jersey roadways. And lastly, the study also calibrates the live load factors for the SHVs for the bridge load rating based on the New Jersey WIM data. First of all, according to the Federal Highway Administration, if the state rating vehicles can envelope the SUs and EVs, that state can be exempted from re-rating for the bridges for the SUs and EVs. Because of this, 75 posting vehicles were collected from 20 states, and those posting vehicles were compared with the SUs and EVs in terms of their load effects. The figures shown below are two examples of how we intuitively present whether the posting vehicle can envelope the SUs and EVs. The y-axis shows the load effect ratios, which is the ratios of the load effect of the posting vehicle versus the load effect of the SHVs and EVs. The conclusion of the figure is that among the 20 states, only North Carolina and Pennsylvania can envelope all the SU4 to SU7, and none of the posting vehicles can envelope the fast-act EVs. As a result, the conclusion of this part is that the SUs and EVs do cause an impact on the load posting policies because none of the states can envelope all of them. And secondly, the statistics of the SHVs and EVs were determined based on the weighing motion data. For the EVs, based on the box plot, we can clearly see that the population of EV3 is much larger than the population of EV2. And we can see that the average daily count of the EV2 and EV3 is correlated with the average daily truck traffic, called ADTT. And according to the histogram in the bottom, we can see that the maximum GVW of EV2 is equal to the GVW of fast-act EV2, and the maximum GVW of EV3 is smaller than the GVW of the fast-act of EV3. Regarding the SHVs, the study analyzed not only the 4 to 7 axle SHVs based on AASHTO, but also analyzed the 2 and 3 axle SHVs. And based on the heat mapping showing on the bottom, we can see that the special hauling vehicles concentrated in the north area of the New Jersey. From the histogram on the top right corner, we can see that the weight of the SHVs increases as the number of axles increases, and there is no 7-axle SHVs were captured by the weighing station. Lastly, the study calibrates for the SHVs live load factors and the weights. The live load statistical models are obtained based on weighing motion data, including the bias ratio, the coefficient of variation, and also the distribution type based on the 5-year return period. And there are 12 loading scenarios were considered, which is basically the combination of the 4 trucks plus the 3 EDTT categories. 131 steel girder bridges were collected from the previous study, and for all of those bridges, the reliability index beta and the rating factors were calculated, and a total of 12 plots of the reliability index versus rating factor was created, and one of the plots is showing on the below. And the purpose of the calibration is to make the rating factor equals to 1 when the reliability index equals to 2.5. Based on such methodology, the team proposed the alternative 1, which is to adjust the live load factors, and as you can see, from SU4 to SU7, the live load factors gradually decrease, and the variation is relatively large. Because of the large variations, the second alternative was proposed, which is by using both the adjusted weight and also the adjusted live load factors. As you can see in the second table, by increase the SU4's weight and decrease the SU5 to SU7's weight, the live load factors of all of the trucks are remaining relatively uniform, which is equals to 1.4. And this is the end of the poster. Thank you for listening.
Our third and final poster presentation for today is titled Effect of Thixotropic UHPC on Interfacial Properties as an Overlay, presented by Guillaume Du of Stevens Institute of Technology.
Hello everyone, this is Zhang Du from Stevens Institute of Technology. My advisor is Dr. Weina Meng. My topic is about effect of 6-tropy UHPC on interfacial properties as an overlay. Ultra-high performance concrete is a new type of cementitious composite, has high mechanical strength, strain hardening behavior, super workability, and extraordinary durability. The ultra-high performance concrete is an emerging solution for new construction and repair of bridge deck overlay for service life extension. However, there are some problems when used UHPC as an bridge deck overlay. The typical UHPC is self-consolidating, which is highly flowable and non-6-tropic. This non-6-tropic UHPC will flow on the crown due to the 2% slope of the structure. Therefore, numbers of formworks will be needed to shape the UHPC mixture into a crown with the required slope. The requirement of formworks will further increase the construction time and cost. Therefore, the purpose of this study is to address these challenges through developing a 6-tropic UHPC to allow construction of the overlay without any formworks. 6-tropy is a time-dependent shear thinning property of non-Newton fluid that behave as a solid under static condition and change to the fluid by agitating or vibrating. The two figures here show the difference of non-6-tropic UHPC and the 6-tropic UHPC. The non-6-tropic UHPC is highly flowable, while the 6-tropic UHPC is easy to work with during the casting and can hold its shape after the casting process is done. Due to this unique behavior, using 6-tropic UHPC as bridge deck overlay can accelerate the construction by eliminating the formworks. Two main factors can affect the 6-tropy UHPC. One is the purified and thermal-treated nanoclay. The investigated count was 0.05 and 0.10% and 0.15% and 0.20% by mass of binder. Then the other is the temperature. The various temperature, such as 10 centigrade, 25 centigrade, and 35 centigrade, were used to mimic the typical environmental temperature on job site. High-precision rheometer and Antonpar MCR300 were used to measure the dynamic yield stress and static yield stress of UHPC with different nanoclay addition and temperatures. The Bingen model was used to fit the curve of corresponding shear rate and shear stress to determine the dynamic yield stress. The shear rate control protocol was used to determine the static yield stress at different rest time. The growth rate of static yield stress is defined as 6-tropy of UHPC. Direct shear test and pull-off test were used to evaluate the interfacial properties between 6-tropy UHPC overlay and substrate. The 6-tropy UHPC are sensitive to vibration. So, three types of vibration energy were introduced, such as non-vibrated, middle-frequency vibrated, and high-frequency vibrated in this study. The linear relationship between mean slump value and rheometer properties will be established to facilitate the control of 6-tropy of UHPC mixture on job site. As a flow test is easy to conduct, the optimal 6-tropy for different temperature will be determined based on results of workability and bonding strength between UHPC and the substrate. So we can see the results. It's clear to see that both addition of nanoclay and increment of ambient temperature increase the dynamic yield stress and 6-tropy of UHPC. The difference is that the nanoclay addition has greater impact on the increase of dynamic yield stress, but the temperature changes have greater impact on the increase of the 6-tropy. It's also observed that the bonding strength decreased with the increase of the UHPC 6-tropy. To further improve the bonding strength for certain application, some degree of vibration can be applied. As can be seen in this figure, when the highest amount of nanoclay was employed, the bonding strength improved with the increase of the vibration energy. So in the future study, the pull-off test will be tested on the 6-tropy UHPC with the conventional concrete substrate. The optimal 6-tropy range for UHPC as an overlay can be selected. The complete results will be published in the near future. Second, the effect of vibration energy on bonding strength of 6-tropy UHPC at other nanoclay addition and temperature will be studied. Finally, the effect of nanoclay on shrinkage, hydration, microstructures development, and mechanical properties and durability of UHPC will be further investigated. Thank you very much. This is all my presentation.
Now the question is, person is wondering how SHVs and EVs compare to more typical vehicles when it comes to loads.
Hi, so basically the SHVs are kind of special configured and they have the closed axle spacings. So while the SHVs are on the bridge, it can cause more moments as well as the shear. So it's kind of legal loads, but can cause more load effect.
When performing the literature review of your research project involving SHVs and EVs, did you review this one document that Stephanie mentioned that New Jersey Department of Transportation has posted?
Yes, actually I just reviewed, and when I do the research, I stick onto the memorandum itself and also the Q&A documents. But for the second one, I didn't really review it before, and I need to review, and I will review. Yes, thank you for providing the literature.
Okay, that seems to be the questions for yours right now. Thank you very much.
Thank you.
Let's go on to the next poster. Do you know if New Jersey DOT has done research on UHPC before on bridge decks?
Yeah. There is some research we can see in the chart. Some I think staff sent the document for me. NJDOT has some experience with the UHPC, but I think on the bridge deck overlay. This is a new type of UHPC. It's a thick tropic UHPC. So I think there is some research about UHPC before.
And we do see, hopefully everybody sees in the chat that you can see that the New Jersey DOT experience with UHPC does include the Pulaski Skyway, and they do have some notes that you can pull up there, a few links that you can use. We do have a question of, this is for the HHVs now. Were some of the applications for SHVs on our bridges, they indicate they would travel at low speeds?
Could you please repeat the question, because I kind of don't understand the question.
George, if you want, I can turn your mic on if you want to ask that question. George, if you want.
Yeah, can you hear me? So we have every once in a while we get an application for some of these SHVs. They're hauling, certain. They're very unique axle configuration and so forth. And we've done some analysis, but one of the things that they've indicated is that they will travel at a slower speed. I'm just wondering what structurally, if that makes any difference in terms of dynamic loading, or if that makes any difference in terms of the analysis, because it's really just based on weight, I guess, and axle spacing, right?
Yes. So basically, regarding the dynamic, we don't study dynamic impact of the SHVs in the study, and we basically do the line grid analysis to process the load effects. So for your question, I don't really have a good answer. So I'm sorry for that.
That's fine. No, I just, again, and obviously if they're traveling at a slower speed, it's going to, it's going to impact traffic and so forth. So I just asked because, it seems like they have some more wisdom on it than maybe I do. I don't know.
Yeah.
Okay. Thank you.
It's appear we lost Mohammed at this time. So I'm going to turn it back over to Dave for closing remarks. So thank you for all of our poster session people.
Okay, this concludes today's program. Please join us again tomorrow at 9 a.m. as we kick off for the third and final day of the Virtual Research Showcase with presentations representing mobility, safety, resilience, and more. Please leave any questions in the chat pod. Thank you and enjoy the rest of your day. See you tomorrow.